So I've got an example here for us to think about where we'll be able to apply, because we're going to do this two ways. So we'll be able to apply both of the formulas that we derived in the last lecture, both the formula for the present value of a continuous investment and the one for the future value of a continuous investment. So what we've got going on here is I'm saying, suppose you've won a major singing contest with $1 million prize, right? And this is often the case with these things. You don't really know this if you're watching the show. You kind of have to read the fine print at the end. They really don't just give these people $1 million check, right? Instead, they'll do something like what I've got here. You can get $100,000 payments every year for 10 years, or you can get a single one-time payment of $850,000. And my question here is, which is the better offer? And so for comparison purposes, we're going to assume that the payments can be invested at 4% and that it's going to compound continuously. Now, as I said at the end of the last slide, at the end of the last lecture, you're really not going to find an investment that compounds continuously, right? But by doing it this way, what I'm doing is I'm finding the upper bound on how much we can hope to make, right? And if the upper bound of doing it one way is less than the value from doing it the other way, then I know which way I should go. Okay, so the problem here is these are in different time frames. Right? One of them is a single payment, where the other is in these annual payments. So to make this comparison, to make this into an apples to apples kind of situation, I need to do one of two things. I need to either take both options and turn them into the value of that choice today. I'm thinking in terms of the present value, or I need to take both of those choices and turn them into the value at the end of the process when I would have received every penny from both options, right? That's the future value option. So I'm going to do the present value option first, all right? So what I want to do um, is calculate the present value for both of these scenarios. Now, I really don't have to do it for the second one. For the second one, the present value is that single $850,000 payment. Right, so really, I only have to do these calculations for the annual payment scenario. So I've set this up here, and we're calculating future value, right? So I'm using our future value formula. The future value equals P E to the negative RT. And what I've done is I've laid out these ends over here. These are the years, right? That's the year at which the payment is made. And the payments are all the same. They're always $100,000. You notice I started at t equals 0 because on day one we get that first payment, right? So what is the future value of this? How much money would it take? How much money would I have to invest to end up with that $100,000 that I get instantaneously? Well, hopefully it's kind of intuitively clear to you that that's just the $100,000. And the formula supports that because right, this is e to the 0, which is 1, and yeah, sure enough, that's a thousand, the $100,000. So now at the end of the first year, I get the second $100,000 payment. So this is the future value of that. That's how much I would have to put into the account on day one to have $100,000 on day 366. Right, and now I've done this repeatedly here, right? On the beginning of year, excuse me, the beginning of year two. So I get $100,000, and this would be its future value, and so on. You notice I only went to 9, right? I did not go to 10 because I get the first payment in year 0. I get the second payment at the end of year 1. The third payment at the end of year 2, and so on. So this is the 10th payment, which I would get at the beginning of year 9. Okay, so I have all these future values here, and you're welcome to get your calculator out and check my arithmetic. But if you do all of these calculations, add all of these up, the grand total is $840, $840,793.77, which is less than the one-time lump sum payment. So what this is telling me is, since this is the maximum amount, right? Doing this continuously gives me the greatest possible return on my investment. Everything else is going to do worse, right? So there's no way I'm going to be able to make more than that one-time payment by investing the monthly payment. So the one-time payment is going to be the better choice here. Okay, now this was fine. There are actually other ways we could have done this. This kind of investment where you get a monthly payment is called an annuity, and there are some formulas for dealing with annuities. But what I really want you to take away from this is the method that I used, right? Where I said, okay, well, look at the amount I get here in the first payment, then calculate its impact. Then look at the amount I get in the second payment and calculate its impact. Then add them all together to get the final result. Right? That's a concept that we're going to use quite a bit in the next section when we start talking about income streams. Okay, so let's take a look at the same question here and do it from the other direction. Right? Let's say, and instead, I ask myself, well, what is the future value of each of these two payment scenarios? Right, so and now we can kind of walk through the table here. Year zero, right? That's day one. You get $100,000 payment. You're going to invest it at 0.04% for how long? Well, it's going to be for for 9 years. It's going to be the whole 9 years until you finally get that last payment, right? That's why I've got a 9 up there. Then at the end of year one, the beginning of year two, you get another $100,000 payment. So how much is that going to be worth at the end of this whole little project? Well, that's going to be worth 100,000. Now I've got 8 because now there's 8 years until we get to the beginning of that 9th year. Right? So that's how long that money is going to sit. And I did the same process here that I did the last time. I worked out all the future value of all 10 payments. And if we add these up, we get $1,205,134.45. Now, we can't compare that to the 850, right? Because this is a future value, and that 850, that's a present value. Right? So what I need to do is I need to do the same thing with that 850. If I calculate the future value of 850,000, that's 850,000 e to the 0.04 times 9. I would get that 850,000 on day one. So it's going to sit for the entire 9 years until I would have gotten that last $100,000 payment. And again, if you go to calculator, work this out, this is $1,218,330. So, which is better? Right, the future value of investing that $850,000 is going to be greater than the future value that I get from investing the individual $100,000 payment. So that's good. We got the same result both ways, right? And again, you notice I used that same technique where I looked at the impact of each of the yearly payments separately and then added them up to get the final result. Okay, so in the next lecture, we're gonna start our next topic. We're gonna talk about something called income streams. And income streams, something I think ultimately everybody who's had a job is really kind of familiar with. Your income that you get from your job, your weekly, bi-weekly, monthly, however often you get paid, those paychecks that come in on a regular basis are an income stream, right? And analyzing the future and present values of income streams is what we're going to talk about in the next several lectures.